And then what you're going to do, copy that diagram so you can reference it, and then we'll go ahead and plot that out. So here's what we want to do. So as best you can, draw in a nice circle. That should not be a difficult task. And then within that circle, draw in something that looks like this. It's a quadrilateral. So initially, just make it all look like this first one so we can kind of understand when you read through that problem what it's asking you for. Quadrilateral has four sides, old idea, and we're now inscribing that inside of a circle so that all four vertices lie on the circle. And then label them with the same letters that I have, so B, C, D, and F, so that when we fill in our table, it'll make sense. Okay, got that. So now, on your notes, what I'm asking you to do, and label them appropriately. So in one column is angle B, one column is for C, and there's a column for D and F. Here's some angles that we currently have. So that'll be our first row. So in the first row of your notes, you're going to put 60, 80, 120, and then 100. So when we go back here, it's in that order. So 60 degrees. Angle C was an 80-degree angle. I forgot already what it was. 120 and 100. All right. Now it's in this order. B is next to C, and then D, and then F. All right. So what I'm not going to do is I'm going to change this. Let's say I move this guy over to here. Notice how when I move angle E, does this angle here change? No, that one is staying the same, but notice how it does impact the others. So let's go to here. So let's say I made it that way. Record those values, 70, and then 80, 110, and then 100. So 70, 80, 10, and then 100. All right, and then one more, and then what we're ultimately let me change some other ones now. So let me actually change this one up here. We'll make this, say we do it that way. All right, record those. Then what we're ultimately looking for here, and this is what's in words, what's explained or asked of you in words. We talk about consecutive angles and we talk about opposite angles. All right. So I'm going to change this one more time. So it's a little bigger to look at. So let's do this guy. So if I ask you angle B and C, notice how B and C are next to each other. It's the very next angle. So those are adjacent. Angle C is adjacent to D. They're next to each other. D is adjacent to E, and then E is adjacent to B. So that's our adjacent angles. If I ask you opposite angles, what angle is opposite of angle B? Well, D, right? So B and D are opposite. If I go to C, angle C and E are opposite of each other, okay? So what we want to kind of recognize, if you look at your table, it might even be easier for me to have this kept up here for you to answer this question now. If we go down here in letter A, and it says, is there a relationship between consecutive angles, angles that are next to each other? All right, and if so, what is that relationship? So if we go back to this diagram here, this was 70 and 90. So when we add those up, those are 160. If I add these up, those are 200. If I add these up, I suppose those are 200. And then if I add these up, these are also 160. Okay. It also asks about opposite angles. So let me make these nice numbers. Look at your opposite angles. See if there's any sort of a pattern there. All right. So if I ask you opposite angles, is there anything interesting happening between B and D? And then opposite angles here, C and E. What do we think to that one, Armando? Good. So if we kind of remember the word supplementary, supplementary means what, Armando? Good. So if we added the B and the D together, notice how they add up to be 180. If I add C and E together, they add up to be 180. Let's switch them. Let's say I move this over here. So we'll do 85 for those. And then we'll change these to make it more obvious. All right. So even as I move them, isn't 80 and 100 still 180? And then the opposite angles here, I also change 85 and 95. When we add those guys up, all right, those are going to add up to be 180 degrees as well. So on our paper, the big one that we want to write down, this is what letter B is asking. All right, this is the one that we recognize. Is there a relationship between opposite angles? And if so, what is that relationship? All right, that relationship is opposite angles are, and then Armando used the correct word for this, supplementary. They're going to add up to be 180 degrees. Okay. So now, if that's the obvious one, let's go back to this other one and see if that's what happens with consecutive angles. So consecutive, let me make these nicer numbers here. Make that 80. Okay, what about our consecutive angles? Do these add up to be 180? No. Do these consecutive angles add up to be 180? Let's add them up. 90 and 80, these guys add up to be 170. Do these guys add up to be 170? No. So as we kind of look around, like these add up to be 190. These guys add up to be 170. They're all adding up to be something that's different. So when we start talking about these guys inside having consecutive angles, there's not going to be much of a relationship with them for us to really worry about. So the consecutive angles, you're going to say, no, we're not going to go too much into the explanations of these. There's so many things that kind of just get memorized. But definitely the big one here that we're going to use is that opposite angles in a quadrilateral that's inscribed inside of a circle are going to be supplementary. Okay. So that's one of the new little properties in addition to all the other ones that we were working with last week that you're going to need to get memorized. All right. All right. The next one that I want you to sketch in. So this is in number 2. So now go to number 2 and draw in this figure. So now we just had a triangle. A circle, and then you put a quadrilateral inside of it. Now draw a triangle, and then as best you can, try to draw in a circle. Actually, I might change it a little bit so it's more obvious. I'm going to draw it like that so it's a little more obvious. But try drawing a triangle, and then draw a circle that touches each side of it. Let's see who our artists are out there. And this is going to be a big one. This is one of the more common ones. One of the more common ones that I'll ask now that we see it when it comes to SAT stuff. Really, really common question here. All right, so get that figure, and then when you look at your notes, it is asking you in letter A, what type of angle is formed when the radius? So I'm going to do this radius right here. I'm going to talk about the radius drawn from A to G. And the reason I drew it this way, do we agree A to G appears to be a vertical line going straight up and down? All right, so it says, what type of angle? I'm just reading in your notes this letter A right here. What type of angle is formed when the radius and your tangent line meet? So let me go back to this. My radius is a vertical line. The line tangent is the line outside of the curve that touches the curve once and only once. So this is our tangent line. So the reason I drew it this way so we can see pretty clearly this is a vertical line. Would we agree that this is a horizontal line? And whenever a vertical line and a horizontal line meet, what sort of angle do we get right there? Those two lines are always what to each other? It does in this case, it would bisect. In terms of the angle, though, if I ever have a vertical line and a perpendicular line, they are what to each other? What's that? What is it? Not congruent. Starts with a P. Say it louder, Omar. They're perpendicular to each other. Anytime I have a horizontal line and a vertical line and they meet, they're always going to be perpendicular to each other. So notice how this radius right here and this horizontal line, one's vertical, one's horizontal, that's a 90-degree angle. Even if I swing all this around, so let's say I do the angle F. So if I move all of this around, let's do it this way so that we have a vertical line in this direction. So now look at this tangent line. This is vertical. This radius is now horizontal. Notice how that is a 90-degree angle as well. Okay. So the big one, and this is going to be one of the more common ones, more of the popular ones that you will see. If I ever have a tangent line to a curve, when I draw a radius out to that tangent, that is always a 90-degree angle. All right. So the answer to that, what you're going to put is that this is a 90-degree angle. Now, if you actually drew this in, so don't judge me as I try to draw this in, but if I draw in a circle into this, right, not terrible, and I draw in a radius, it's this angle here, that's that 90-degree angle between the radius and the tangent line. This angle here, also a 90-degree angle, and this radius to that tangent, also a 90-degree angle, okay? So a tangent line to a curve always intersects the curve at a 90-degree angle. Okay, it's not too bad, actually. I'm happy with myself. All right, and then last but not least, you can fill this in if you want. I think this will be pretty obvious. This is a pretty simple one. So if I go to our, I do want you to draw this in, though. So draw in what this looks like. So largely the same thing. And then once you have it drawn in, go ahead and label these two angles. We'll start with the ones that I currently have. So put a 46-degree angle down here. Put a 134-degree angle right here. All right. Yeah, so 134 and 46 is what it was, I think. All right, so those are our first two. Let me say I change this now. So let me say I move this a little bit closer. Notice how this angle gets bigger as we get closer. Look at what your next angle is here. This is a 60. That is 120. So on our table, we fill that in. You're going to get 120 and 60. And then let me give you another one that would be obvious. We don't have to do any too much mental math here. Let's say I extend this out to be a 40. Notice how when this is 40, this guy is 140. All right, so if we come down here, 40, 140, understand what we've done here. So it's the same thing that we had before. We know this angle right here, these are both 90-degree angles where the tangent line touched, this is a radius, this is a 90. But then those opposite angles formed by those two tangents and the central angle, these are always, again, all right, what word are we now using here? Who came up with that last time? Armando, what are these guys? The 140 plus 40. Weren't you the one who told me that? Yeah, these are supplementary. So when we have these two tangent lines intersect a circle, the angles that are opposite of each other in there are going to be supplementary. Okay, and those are our three new things that we want to now keep straight. Okay, so right, that's what you're asked for in this guy. How is the measure of the exterior angle formed by two tangent lines? So that's referencing this exterior angle formed by two tangent lines. Related to the measure of the central angle, this is your central angle, and then that is they are supplementary. Okay, they're supplements of each other. So, all right, so those are our three new rules. So, practice problems. So Ms. Krupa is going to give you this, and let's see if we can now put all of this together. All right. So old ideas, new ideas, see what we remember from the weekend. So when you get this, do 1 through 4 when you get these. And see what we remember from last week. And then we'll get to some harder ones, some newer ones. Okay, do 1, 2, 3, and 4. One and two are basic rules. 3 and 4, you're going to kind of put those together. Old ones, see what we remember. All right, let's see where we're at here. Karina, number 1, what'd you get? Karina, I just looked. You're lying to me. Oh, maybe I was looking at you upside down. What'd you get for number 2?
32.
Good. So number 2, she had done. Should get 32. This is what we called an inscribed angle. An inscribed angle is on the circle, and the angle is always half of the arc that it intercepted. So that was one of our basic rules from last week, with nothing else involved. Just do we know the rule? Do we not? All right. When I go to number 1, so now number 1, Mo, what'd you put for number 1? Good. This is a central angle, and whatever that central angle is, it's going to be equivalent to the arc that it creates. All right. So those are basic, straightforward. Just get those memorized. We obviously added some layers to that and that homework assignment you just got back, but those are our two of the basic rules from last week. 3 and 4, put these together. So what you have to understand is that if this was a 68-degree angle, then the arc here that it intersects has to be a 68-degree angle. So that's one of those properties we just did in numbers 1 and 2. And then now that we know that that is 68, we can deal with the other property that we talked about in number 2, that this inscribed angle needs to be half of this. So this angle would have to be a 34-degree angle. X is 34. Okay. So now we need to know one to get the other. All right. Whereas in number 4, I am telling you that this is 72. So then the arc that it intersects, if this is 72, Joel, what would the arc here have to be?
136. Or 144.
Okay, yeah, 144. I was confused myself there. Yeah, so that's 144. 72 is half of the arc. So that's our rule that allows us to know the arc. And then if we know that's 144, then this has to be what, Joe?
144.
Good. Then X has to be 144. So the central angle has the same degree measure, and the inscribed angle has half of that measure. Okay? So that's 2 of our rules that we want to keep straight. For the first time in that Delta Math, I gave you those last 2 questions were a couple little algebra problems. Okay, so if you haven't done those, some of those are the ones that people are getting stuck on. We're going to introduce those a little bit more now. So in number 5, try to set something up for this one. Same exact concepts as 1 through 4, except now we have a little bit of an equation, a little bit of an algebra concept to this. but don't overthink it. Same thing you would have done in 1 through 4. All right, Julia, you're writing frantically over there. What did you set up? Equals what? Good. Isn't this a central angle? And isn't the central angle, so like right up here, if this was 75, then this was also 75. A central angle and the arc are the same. They're equal to each other. So this here is your central angle. That's 3x minus a 4. That has to be equivalent to whatever the arc value is, which is 80. Okay? That's our equation. That's what we're going to set up. We're all good at solving equations as long as we can get them set up correctly. So you're going to add that 4 over. Divide by your 3. What'd you get, Julia? Good. And then that should give us 28. All right, 6. Try to set that one up. A little trickier. A few more mistakes on this one here. Okay, so with this one, it's about 50-50 looking over here. Let's say this wasn't here. Let's say I didn't give you this x plus 8. So let's say that wasn't there. And all I was asking you for is what's the degree measure of this angle? So if we revisit, this is an inscribed angle. If we go back up to the basic rule here in number 2, if I know my arc is 64, then this angle is half of that. All right, so that's the basic rule. So now we're going to introduce some algebra concepts with these. When we go to number 6, if I were to ask you what this angle is, shouldn't it be half of 110? So if I want to know what this angle is, doesn't this have to be a 55-degree angle? Yeah. So when we now introduce this and erase and kind of find this x plus 8, what I need to be doing is taking x plus 8. What does x plus 8 have to be equivalent to? Well, yeah, it's got to be equivalent to that 55, not the 110. Okay? So that's our degree measure of that angle. This is what it is written as a variable expression. So this should be the equation that we are setting up. Okay? So if you did that correctly, you should have gotten x to be 47. All right? So know if you're having it, if we're setting it equal, sometimes you're going to have to double. It really depends on what you're given. All right? 7, another little trickier one here. Old idea, see what you think. Because in 8, 9, and 10 are really pretty simple, sort of. At least number 8 is, but it's the new stuff. So see what you think for 7. This one's pretty hard. Let's see if we get it. Yeah, you do get a decimal. You did it correctly. Yeah, you get 20.6 repeating. You got it. Not do it up here. Okay. Here's a really bad drawing that I'm trying to reproduce over here, and I'm going to use numbers instead of variables so we can kind of understand how this equation would get set up. If I had told you, like on the front page, if I had told you that this is we'll say this is about 60 degrees. So if this was a 60-degree angle, doesn't that mean this arc, if this is a 60, isn't this always 1/2 of the arc? So doesn't that mean the arc is 120 degrees? And then when we revisit this central angle, the central angle would have to be which one of those, 60 or 120? 120. So when we look at those two angles, all right, this angle here, which is 120, and this angle here, which is 60, aren't those the two angles that we're looking at right here? Are those equal to each other? No, those are not equivalent. But what we need to do, what would we have to do to this angle right here to make it equivalent to that 120? Well, yeah, we've got to double that angle. So what I need to do to make that angle equivalent to 120, because if you got it right, you were doing that. If you didn't, I saw a lot of people doing this. But what you're saying is a 60-degree and 120-degree angle are equivalent, and that's not the case. So what we need to do is take that smaller angle, the inscribed angle, and just like we would need to do to the 60 to double that to be 120, we need to multiply that by a 2. We need to double it, and then it would equal the 5x minus an 8. All right? That's where our equation now comes from. So a little sneakier when we start introducing variables and algebra to it, but it's still those same rules. If I do it with the numbers, most people probably have a decent handle on it. This is just kind of the next iteration of this when you have to do this with some algebra. So 2 times x is 2x, 2 times 54, or 27 is 54. And then you do get an ugly number, unfortunately, but that doesn't necessarily mean you're wrong. But I know people start doubting themselves when it's not good. So add that over. And we get 3x equals 62. And then when we divide by 3, that's the weird 20.6 repeating, or 20.7. All right. All right. Those are a lot of our old rules from last week. The last 3 problems deal with the 3 rules that we just talked about today. So do number 8. If you have your notes and you wrote it down, this is super quick and easy. Oh, I actually have it up. Perfect. Oops. All right, here's our 2 tangent lines. This is the exterior angle created by that, and we want the angle that is opposite of it. This is actually the very last one that I had up on our little diagram here. Aren't these guys supplementary to each other? So if that's 40, this has to be 180 minus 40, which is 140. All right, so that's the answer to number 8. That was the last one we actually left off with. All right, number 9, a little algebra version of this. Try to set something up for number 9. Exact same as number 8. Exact same little theorem that we got to get memorized, but obviously a little sneakier. See what you think for number 9. Another one, if you can think this through and get a pretty good sign, a pretty good indicator you're understanding this. Not an easy one. Sure, this is a good number too. We get 57 if you do it correctly. 57. If not, we'll take your thing and see if you come up with it. Okay. Here it is. That discrepancy. Pleasantly surprised. Okay, let's walk our way through this one. I'm going to revisit number 8 here because I'm going to use the same thought process in number 9 that we use in number 8. And that is if I know this exterior angle, then the angle opposite of it, which is ultimately the central angle, we know is supplementary to it. It's got to be 140. Okay, so that we had on our computer, hopefully a pretty straightforward one. When I revisit this problem, it's the same idea where if I know this is 72, doesn't this angle here have to be the supplement of this? So not quite as easy of one to just do in our head, but do 180 minus a 72. That means that that central angle has to be a 108 degree angle. All right. So that's the same thing we just did up here. 40 and 140 add up to be 180. 72 and 108 add up to be 180. And then now what we do is rely on our old rules that if this is our central angle, that's 180. Doesn't the central angle have to be equivalent to whatever the arc measure is going to be? So that 108 degrees has to be equal to whatever this arc is. They're equivalent to each other. This arc, though, I'm defining with an expression, the 2x minus the 6. Okay. And then that's our equation. That's what we work our way through and solve. And then that should be what gives us 57. All right. We add that 8 over, or add the 6 over, divide by 2, should get 57. Okay. All right. Last one, number 10. Try number 10. This one, not so much. Okay. This one, not so much. Let's talk about this. Here's what this rule is testing you on. It was this guy here when we talked about how if I have a tangent line to a curve and I draw a radius out to that curve, what degree measure is that angle going to be? 90, right? So if we look at the picture of ours, here is that tangent line to the curve, to our circle. Here is the radius. So there were a hand of people doing it right. A couple of those understood what to do, kind of assigned the values to the wrong spot. This here is a right angle. Doesn't that simply make then a right triangle here? We could do the bottom one as well. I'm just shading in the top one. You could do the bottom one as well. Isn't that really just a right triangle? And we know 2 of the 3 sides. All right. So again, we have revisited this quite often now recently. But if I know 2 sides in a right triangle, don't we find the third side with good old-fashioned Pythagorean theorem? A squared plus b squared equals c squared. This is your right angle, though, so understand the hypotenuse is the x. That's what we're looking for. And then the 3 and the 4 are the a and the b. Okay, add those up. This actually ends up being a nice number. So 3 squared and 4 squared, 9 and 16. X squared is going to be 25. Take the square root of both sides. Again, when we do square roots, we're supposed to be always getting that positive and negative solution, positive and negative 5. We don't do that often right now, and we still don't ultimately because it's a length, so you're never going to get a negative length. But just keep in mind we should be getting that, so in this case, you should get a 5. Okay. Okay, that's it. No homework. I want to kind of do some more before I'm going to trust we can do these on our own without a lot of questions the next day. So you're spared today, but tomorrow we'll add a few more and then we'll get some homework tomorrow for sure. Yeah, go ahead. See you, Tyler.